Okay, let's get started with part 6. And today we're going to talk about exponents, more specific into exponents. Okay, and I really want to get into variables instead of using numbers, but I want you to see that they work for everything here. Variables and numbers work. So I'm going to make this little chart here. Make a chart. And I'm going to let x be real. However, x is not 0. Okay, so this doesn't work if x is 0. So we're going to use a number just to help you visualize the situation, but I want to get you more formulated into the variable form here. And I hope I left enough room, and then the expression. Okay, so yeah, let me make this just a little bit better this way. Okay, all right, give me a little bit more room. Okay, so I want to start with the number 3, and the variable I'm going to use is x. Okay, so I'm going to have a chart here. If I have 3 times 3, because we're talking about exponents, that's also, if x is 3, we could use that as x is x, and we learned from the last lecture about the laws of exponents that if I multiply something by itself twice, it could be 3 squared or x squared. Okay? So I want to try to find a pattern here so we can talk about different types of exponents. Okay, so what if I have 3 times 3 times 3, and again, as I multiply, I'm going to multiply by the same thing going up. This is going to be x times x times x. And the pattern here is that this is going to be 3 cubed and x cubed in exponential form. So we can just kind of make a little chart here, exponents. Okay. And then the next one will be 3 times 3 times 3 times 3. This would be x times x times x times x. And this would be 3 to the 4th. And in variable form, it'd be x to the 4th. Okay, so you can see as we go up here, as we multiply, we go this way, up this way, we're multiplying. Okay, and the next one would be 3 to the 5, which would be 3 times 3 times 3 times 3. And this would be x times x times x times x times x. And this would be 3 to the 5th. And this would be x to the 5th. So I want you to see the pattern here. As I multiply by the same number going up this way, the exponent, here I'm multiplying by 3. Here I'm multiplying by x. And this way the exponent is increasing as I go up. And this way the exponent is increasing as I go up. Okay, so what we really didn't talk about maybe is what happens if I go down? Okay, so this would be 3. Well, you can see that the exponents are going down. This obviously should be 3 to the 1 because the exponent is 5, 4, 3, 2, 1. And this exponent pattern down this way would be x to the 1. So here's our first rule that we found off this chart is that anything to the 1 power is itself. And this is regarding that x is not equal to 0. So we're going to make sure that we understand in this situation that x is not 0. Okay. Well, what happens if we keep going down? What's 3 divided by 3 here? Well, 3 divided by 3 is 1. Right? X divided by x is also 1. We'll just go call this x divided by x is 1. All right. Well, I keep decreasing in the pattern here. This would be 3 to the 0, and this is going to be x to the 0. So this rule here, we just created a rule here. I mean, this is just an example using a number, but the pattern for x here means it applies to any number as long as x isn't 0. And this is why x can't be 0, because you can't divide by 0, right? So x cannot be 0. So any number besides 0 to the 0 power is 1. Okay, so now this is where it gets interesting. Okay? What happens if I keep going? downwards. Let me kind of make this chart just a little prettier. What if I keep going downwards? Well, I'm going to keep dividing by 3. So here I have 1 divided by 3. And of course, this would be 1 divided by x. And x can't be 0 because we can't divide by 0, right? Well, here's the exponent here, 3 to the negative 1. And this would be x to the negative 1. So here is what we call the reciprocal rule. The reciprocal rule. And that if we have 1 divided by x, that is x to the negative 1 power. Okay, so I want to keep continuing on in this pattern and see if we have, see if we can figure out what we got here. Okay, so if I keep dividing by 3, that means I'm going to be multiplying by 1/3. So this here is going to be 1/3 times 1/3, which is 1 over 3 times 3. And instead of writing this twice, I'm just going to write this as 1 over x times x, because if the pattern works for 3, it's going to work for x. So what happens here? Well, we keep going down. What's 1 less than negative 1? That would be 3 to the negative 2. And 1 less here would be x to the negative 2. Okay. So I'm going to keep dividing by 3 here. Here I'm going to have dividing by 3 and multiplying by 1/3 are the same thing. So here we're going to have 1 divided by 3 times 3 times 3. And this is going to be 1 divided by x times x times x. And this is 3 to the negative 3 and x to the negative 3. And we'll do one more. I think this is enough to see the pattern. And this is 1 over x times x times x times x. And this is 3 to the negative 4. And this is x to the negative 4. Okay. Well, this is what we call the negative power rule. And I want you to see the pattern here. Negative power rule. Okay. Now, I want you to notice that 1 over x is x to the minus 1. And 1 over x squared is x to the minus 2. And 1 over x cubed, this is 1, 2, 3, right? 3x's, that's 1 over x cubed is x to the negative 3. And 1 over x to the 4th is x to the negative 4. So if I have 1 over x to the n, that is x to the negative n, where n is an integer. Okay? N is an integer. Because I keep going down, this could be positive 3. And one thing to note here, x to the negative n is equal to 1 over x to the n. Which is the same thing either way. So in other words, with this negative power rule, if you have I'm going to spell this out in English. If you have a negative exponent, it is a positive exponent. It is equivalent, well, I'll say it that way. It is equivalent to a positive exponent on the other side of the fraction. I don't know how well you can read this. If you have a negative exponent, it is equivalent to a positive exponent on the other side of the fraction. Let me show you some examples of what I mean. And I think we have these rules here down. Okay, so if I have x to the, we'll just use other variables, okay? And here, x, y, and z are not 0. N, well, we're not going to use n. We're not going to worry about that. If I have x to the negative 3, that's 1 over x cubed. Okay? Here, this is like in the numerator, it's positive in the denominator. What if I have 1 over y to the negative 2? That would be, if it's negative in the denominator, that's going to make it positive in the numerator. So this is the same as y squared. What if I have z cubed, z to the negative cubed, divided by y to the negative 1, z squared, x squared. X squared. So I have z to the negative cubed, y to the negative 1, x squared. Okay. Well, let's simplify this. Well, let's start with this numerator here. Here, z is negative in the numerator, the exponent, so it would be positive in the denominator. Here, y to the negative 1 is negative in the denominator. It's going to be positive in the numerator. And x squared is not going to move because it's positive in the negative, positive in the denominator. So to simplify this, you would get y divided by z cubed x squared. Okay? So the moral of the story, if you have a negative exponent, it is equivalent to a positive exponent on the other side of the fraction. Okay, so that just took care of negative powers, power of 0, reciprocal rule, and 1. Let's look at some more rules of exponents. And this one is probably the most important rule. And I'm going to leave this up right here, my great example, x to the 5th, to use as an example. Okay, so here I claim that x times x times x times x times x is equal to x to the 5th. All right, so let me break this down just a little bit better. What if I have x times x times x times x times x? That's still x to the 5th, right? All I did, we used the associative law. All this did was change these two. Well, what is this? This is x cubed, and this is x squared, and they're still multiplied, right? Or I could do 4 and 1, or I could do 2 and 3. Either way, all these exponents add up to 5. And that brings us to the power rule, which is power product rule. Say that 10 times real fast. Backwards. Power product rule. Okay? Power product rule is that if we have, we're going to use x and y are real numbers, x and y not 0. And we're going to say a and b belong to z for now. Okay? So a and b are integers, and x and y are real numbers. I can make any rule out of this such that x to the a times x to the b, so we have the same base here, x to the a times x to the b is equal to x to the a plus b. Okay. X to the a times x to the b equals x to the a plus b. Now, I want you to think back to the first lecture we talked about addition and subtraction, multiplication and division. Here we're multiplying. What is the inverse of multiplication? Division. So what if I have x to the a divided by x to the b? Okay. Well, if I do the inverse of this side, I do the inverse of this side as well in most cases. In this case, it does work, and we're going to prove it. This would be a to the minus b, right? Now, I want to prove this about 2 different ways. First way I want to prove this is what we just talked about. What happens if something's in the denominator, negative? What happens when it switches sides? It changes sign, right? So if it changes sign and it comes up here, I'm multiplying. And this would become negative b in the numerator, and here we'd have x to the a minus b. That's one way to do it. Another way to do it is just to say, okay, we got x to the 5th divided by x cubed, right? And what is x divided by x? We already talked about that. It'd be x to the 1 minus 1, which is 0 power. And what's left is x to the 5th divided by x cubed, which is x to the 5 minus 3, which is x squared. So however you want to prove it, this is the quotient rule. The quotient rule for exponents. Okay. Next. All right, so we're going to keep the same rules here. X and Y are real numbers. Non-zero. A and B belong to the integers. So A and B are integers. Okay, the next rule. What if I have x to the a, and I'm going to raise this all to the power of b. All right. So let's look at an example of what we would do with numbers, okay? So I'm still going to use x as a variable. Let's say I have x squared, and I'm going to cube it, okay? Well, this is going to be x squared times itself 3 times. X squared, x squared, x squared. And you may see that this is repeated addition, which we talked about, that was multiplication. This is x to the 2 times 3. So when we take a exponent to a power, we multiply the exponents. This is going to be x to the a times b, and this is the power to a power. We'll just power to a power. This is more important. I'd rather you understand the rule rather than what the name's called. You could call it the banana rule for all I care. This, I want you to understand how this works more than the name of the rule. But I do have to call it something, okay? All right. And I left the flash on. I hope this video comes out okay. And we have 2 more. What if I have x to the a? I'm going to add a c on here as an integer too. I have x to the a times y to the b, and I'm going to raise all of this to the c power. Okay, so based on this rule we just had, we can make this as x to the ac times y to the bc, and really this is no different than this rule except that we have a product in here. So we're raising all this. This rule would be x to the ac, y to the bc. All we're doing is raising each individual factor to this power. Same works for quotient to a power. Let's say I have x to the a divided by y to the b, and I'm going to take all this to the c power. Well, you could just see that as we multiply across, if I wrote x to the a over y to the b multiplied by itself, c times, the numerator is going to be x to the ac, and the denominator is going to be y to the bc. So, when you're taking a quotient to a power, you multiply the exponent. So this would be x to the ac in the numerator, and then yb to the c in the denominator. And that's going to conclude it for lecture 6. This is part 6. There's one more part. We're going to talk about fractions in the last part. And that's going to conclude the first part of the homework. And I hope the glare on this board with the flashing isn't too bad. I want to go check it out. And we'll see you soon as I upload this. I appreciate you watching. Check us out on Facebook. Comment, questions. If you want to see the homework exercises for this lecture, email me. I already have the solutions for the worked exercise ready to upload. And we'll see you soon. Thanks for watching.